Good day, everyone. Today we're going to know the building construction process. Step 1. Land acquisition and site inspection. The first and most critical step in building construction is selecting the right piece of land. As a civil engineer, we need to assess factors like location, accessibilities, and the land's potential for development. A well-chosen site can significantly the success and appeal of the building. Step 2. Site survey and soil testing. Once we have our land, it's time to gather essential information about the site. This involves about conducting a detailed site survey and soil testing. A site survey provides information about the land's topography, boundaries, and nearby utilities. Soil testing, on the other hand, helps us determine the soil's load-bearing capacity, which is crucial for designing a safe and stable foundation. Step 3. Design and planning. Now that we have our site information, it's time to collaborate with architects and other engineers to create a design that meets the client's requirements and complies with building codes and regulations. During this stage, engineers develop comprehensive architectural, structural, mechanical, electrical, and plumbing plans. This intricate process requires civil engineers and architects to use their technical expertise and problem-solving skills to ensure a safe, functional building. Step 4. Obtaining permits. Before we can break ground, we need to obtain all necessary permits and approvals from local authorities. This step is crucial to ensure our project adheres to zoning regulations and building codes. Step 5. Site preparation. With all permits in hand, it's time to prepare the site for construction. This involves clearing debris, vegetation, or existing structure and performing earthworks such as excavation and leveling. Proper site preparation is critical to ensure a stable and level surface for our building's foundation. Step 6. Foundation construction. Next up, the foundation, the bedrock of our building. A well-designed foundation supports the entire structure and transfer loads to the ground. As civil engineers, we need to consider factors like soil condition, building load, and design requirements when selecting the appropriate foundation type, depending on the soil's conditions and building requirements. The foundation can be shallow or deep. It's fascinating these parts of the building play such a role in its stability and longevity. Step 7. Structural framework. With a strong foundation in place, it's time to erect the structural framework. This stage is where our building starts to take shape. The structural frameworks, which consist of columns, beams, slabs, and load-bearing walls, provides the backbone for the entire structure. As civil engineer, we need to ensure that the framework is designed and constructed according to the building's requirements, providing a safe and stable structure. Step 8. Masonry. This stage involves constructing non-load bearing using materials like bricks, blocks, or stones. Masonry work not only adds aesthetic appeal to the building but also creates separate spaces and functional divisions within the structure. As civil engineers, we must ensure that these walls are built to the correct specifications and comply with relevant building codes. Step 9. Roofing. Now that our walls are in place, it's time to install the roof. A well-designed and properly installed roof protects the building and its occupants from the elements. As civil engineers, we must consider factors like local climate, building design, and available materials when selecting the best roofing system, from asphalt shingles to metal sheets or tiles. Roofing materials comes in various forms to match the building design and requirements. Step 10. Plumbing, electrical, and HVAC installation. Now that our building has taken shape, it's time to bring it to life with essential systems that make a building livable and functional. As civil engineers, we collaborate and specialized professionals to ensure the plumbing, electrical, and HVAC are designed and installed according to the building's needs and local codes. Step 11. Finishing work. Now it's time to add some flair with finishing works. Finishing works is all about adding the final touches to our building. This stage includes plastering or drywall installation, painting, flooring, and installation of fixtures and fittings. As civil engineers, we coordinate with various trades to ensure a high quality finish that meets both the client's expectation and regulatory requirements. Step 12. Landscaping and external works. Our building surroundings are just as important as the structure itself. Landscaping and external works involve creating beautiful outdoor spaces, planting trees, installing walkways, and constructing driveways and parking areas. As civil engineers, we work. Step 13. Inspection and commissioning. Before our building is ready for occupancy, it must undergo several inspections to ensure compliance with building codes and quality standards. As civil engineer, we work closely with inspectors and authorities throughout the construction process to address any concern and ensure a smooth final inspection. Once the building is deemed compliant, a certificate of occupancy is issued and the building is officially ready
Regular
for use.
maintenance is crucial to ensure the building's longevity and functionality. As civil engineers, we develop maintenance plans and coordinate with building owners and facility managers to ensure the structure remains safe and comfortable for its occupants. And that's all. We have explored the process of building construction from land acquisition to maintenance, and each step plays a crucial role in creating the incredible structures we see and use every day.